Welcome to Unit 4, Notes 3. I have two guests today. One guest is,
Michael Schutte.
I don't know if they're going to hear you. You got to say your name louder than that.
Michael Schutte.
And then we also have
Britta Nielsen.
Britta Nielsen. So they're going to help me out today. So, ax squared plus bx plus c is a trinomial. We're going to do the guess and check method today. So you're going to divide out the GCF if you find one, set up two sets of parentheses, something like that. That looks like our grouping. First two multiply to ax squared, last two multiply to c, multiply inside and outsides, check if it adds to bx. So what we're looking at is you did the box method and the FOIL method. And now we're trying to see if you guys can do that in your head a little bit and guess and check. A, it'll keep factoring simple. And B, it's a lot more easier to do and more fun and more lazy. So, I look at number one. Okay? I would look at this as a 1x squared and a 6. So I'm just going to put my parentheses. Right? 1 times 1. Right? What multiplies together to get 6, but has a remainder of 5? Pick something. I can't do all the talking.
Why never look at me?
What multiplies? What gives us 6?
3.
3 and 2,
Oh.
6 and 1. Okay, but I know that I need a 6 and a 1. Here's why. I need a negative 6. So what I'm going to do is make this a positive 6 and a negative 1. If I check that in my head, this would be x times x is x squared. 1 times x is a minus 1x. Then I'd have plus 6x. And then 6 times a negative 1 is minus 6. So I can work back to x squared plus 5x minus 6. So what we did in black is we guessed and checked with 6. Michael said 3. It's 3 and 2. All right, I went with 1 and 6. So if you can get to the black without factoring by grouping or without the x method, just do it. So then in number 2, we have a 5 at the end. So what multiplies together to give us 5? Say that loud so they can hear.
1 and 5.
Britta says 1 and 5, so I know I need a 5, a 1. X is just going to be x. Now notice the 5 is positive and we need to add to get both of them to 6. If you can guess and check this blue one, you're done. Alright? The middle and the bx is going to be confusing sometimes. But we're trying new things, so we're guessing and checking. Number 3, we have a negative 2 at the end. Who's going to guess?
1 times negative 2.
So 1 and negative 2. So I have x and x. Okay, so I agree I'd have x squared. So this is x squared, but this is minus 2x plus 1x minus 2. This is going to result in a negative 1x. I have a...
Positive, so we have to switch the...
So we're just going to go back here, get rid of this.
It has to be a negative 1 and a positive 2.
X minus 1, positive 2. Done. This is correct. So we are just guessing and checking on this video. Do you actually need this to be able to factor? No. But we're going to give you this method so you can do this.
I got this one. So, negative 1 and 5.
So negative 1 and 5. Now this is where it gets a little tricky. We have a 3 here though. So I need maybe a 3x here and an x here.
Yeah.
Okay. So this would have to be positive. If I multiplied this together, I'd have 3x squared. And then outside would be plus 15x. I'm going to stop there. Because plus 15 minus 1 is going to give us 14. I know I don't need 14. I needed a negative 2. So let's go back a little bit. Okay, I would see 3x and x. Okay, it has to be 3x and x because those are the only positive values of 3. It's 3 is a prime number. So 5 and 1 have to be wherever. Remember, we multiply this outside or whatever first. So I should figure out that I don't want to multiply 3 and 5 together. So I have to switch that. Okay? 5 and 1 would have to be like that. Now I got to figure out the negatives. So 3x squared, and then I want it to be plus 3x, and then it would be minus 5x. So that's how I would guess in check number 4. So when this GCF, or this A value, is a 3, it's a little more difficult. Here you go, another 3 1. So these are prime numbers, so they're pretty nice to use. Anybody got a guess for me?
3x and x.
3x and x.
And then
4's got some options, because we have 1 and 4, or 2 and 2 and 2. Now if I do 3 and 4, if I put a 4 here, I'm going to end up with 3 times 4, which is up by 12. I don't think I want that big of a number. What about 3 and 2? What's 3 times 2?
6.
What if I put a 2 here? And made both of these negative.
It ended up being positive 4.
Yeah, so if I check this, this is a nice x. This would be 3x squared minus 6x minus 2x plus 4. I like this. So this is a good answer. So if you guys can jump to that, perfect. Last one, I like 2. Just an x. 5 is a prime number. So we have 5 and 1. Do we want to multiply the 2 by the 5?
No.
So 2 times 5 would give me 10. And I need to get to 11. So if I need to multiply the 2 by 5, I want the 5 at the end and the 1 here. Plus, plus. And I'm pretty confident 2x times 5 is 10x. So just remember, you're going to have 2x times 5 is 10x. And then this middle would be plus 1x. So that's going to show you how to get 11. What do we got here? 7. Ooh. 7's iffy. Okay, because I have the 1 and 4 and the 2 and 2. 1 and 4, 2 and 2. Anybody have any ideas?
The 2 and 2.
2 and 2?
Yeah.
Because what's 2 times 2?
4.
Okay, I got to get to negative 17. What are the biggest values I could choose?
16.
16? How'd you get 16?
4 by 4.
So I want 4x right away, and then I got to put the other 4 at the end. So then this is going to be a x, this is going to be a 1. Now negative 17. So what do both of the signs have to be?
1 negative, 1 positive.
Yeah.
Negative, negative. Let's look at this. 4x squared minus 16x minus my 1x, and then a negative 1 and a negative 4
Negative 5.
is a positive 4.
Okay. I forgot your multiplying.
Michael, you will forever be wrong on my Algebra A math video, as long as I have this. Now, 5 is prime, so I just always start by writing the prime numbers. 9 is not, I'd have 1 and 9 and 3 and 3. Now this one is a little bit easier. 5 and 9. If I multiply 5 times 9, what would I get?
45.
45. Do I want to be by 45?
No.
No. So I'm going to just split up the 3's, I think. How do you feel about that, Britta? Yep. Minus, minus. So I'd have 5x. I'd have, if I did the outsides, I'd have minus 15x. And the insides would give me a minus another 3x. For negative 18x. So I believe that this is correct. Minus 3 is a positive 9. So notice you can check it just here by multiplying the insides together. Outsides and insides. Last two, I believe. So I got a couple things. I got 1 and 4, 2 and 2, and then 1 and 25, and 5 and 5. I have no idea. Let me look.
2 and 5.
2 and 5? To get what?
That'd be 10. Otherwise, it would be 4 and 25.
So you want 2 and 2 and 2?
Or you could do
Or,
1
yeah.
and 4 and then 5 and 5.
4.
End up subtracting the.
Oh, so you want to get 20 and subtract a 5?
Yep.
So I would go 4 and 1, 5 and 5, and then which one's got to be negative? Outside 1, I believe. So 4x and 1x is 4x squared. 4x minus 5 is going to be minus 20x. 5 and 1 is plus 5x. And 5 and that is minus 25. So this is going to work out. That's a nice x to what I needed it to be. So this is pretty good that we can get that on our first try.
It's like a cake.
Now, this last one is awesome because I know it's 2 and 1. And then I know 2 and 1 again. Well, I need 5.
2 and 1.
I can't hear you.
2 and 1 again.
2 and 1 again. But where do I put the 1? Do I put the 2 here? 1 here?
No.
Plus, plus? Why you say no right away, Michael?
Because it would only be
2 and 1 is 2, plus another 2 is 4. So I would have had 2x plus this 2x. That's 4.
Yeah.
So I don't think that's going to work quite how I wanted it to. So if I had to switch them up, I could go x, and then this would be the 2 here.
Yeah.
Because this would be 4x plus 1 more. When it's all addition, should be a little bit easier for you to pick it out. But these two factors are that. So that's trinomials, guess and check. So you got to be able to play around a little bit and make sure those middles come out to what you need. It also helps if you write down the multiples, like I did up here for number 9. Alright, we're not going to give you too difficult ones, but up here, number 9, that's the stuff you want to look at to try and determine. Michael, Britta, thanks for helping out today.
Yeah.
Anytime.